The Uelzen I lock on the Elbe-Seiten canal. This canal links the Mittelland Canal with the River Elbe. The difference in height is 23 metres. Next to it, a new and larger lock is under construction, Uelzen II. They are locks with water-saving basins, which reduce water consumption. Most of the water needed for filling the locks is drawn from water-saving basins next to the lock. These are filled up with the water emptied out of the lock. The rest is taken from the upper section of the canal. And this water, in turn, is pumped back from the lower section at night. Before construction of Uelzen II began, the functionality of the new lock was tested and optimized in a model at the BAW, the Federal Waterways Engineering and Research Institute in Karlsruhe. The staff here built the new Uelzen II lock on a scale of 1 to 20. To save space, the water-saving basins of the new lock are positioned one above the other, to the left and right of the lock chamber. In locks with water-saving basins, large amounts of water have to be moved back and forth between the lock and the water-saving basins as quickly as possible. This gives rise to fast-moving currents, eddies and waves, which could endanger ships by forcing them against the lock walls, for example. The water flows out of the water-saving basins and into the lock chamber from below. This happens very quickly, as we can see when black dye is added to the water from the second storage basin. The ship must be raised as smoothly as possible. Sensors on the ship measure the shear and longitudinal forces it's subjected to and transfer the readings to a computer. In order to make laser beams visible, a milky liquid is added to the water. The lasers measure flow speeds in accordance with the Doppler effect. The changing water levels in the water-saving basins are followed by this ultrasonic water level meter. The tube is connected to the lock chamber and shows the current water level. The ultrasonic meters register water levels in the model precisely to within 1/10 of a millimetre, which represents an accuracy of 2 millimetres in reality. Each of the 4 water-saving basins is equipped with ultrasonic meters on both sides. The changing water levels are conveyed electronically to the measurement booth. Other measured values are fed to the booth as well and processed by computer. The forces acting on the ship must not exceed the admissible values in each case. The forces are registered by sensors at the bow and stern of the ship and shown on the screen. If the water level in the lock chamber rises relatively quickly, the forces change vigorously by several kilonewtons. Only when the water level comes to rest does the ship as well. A lock is a complex system with many dynamic parameters and operates with a high level of automation, both in the model and in reality. The data delivered must be of high quality. So the functionality of the lock is optimized in the model, which pays off both technically and economically. The Uelzen II lock came into operation in December 2006 and is one of the world's largest locks with water-saving basins. As we saw in the model, there are 4 water-saving basins on each side of the lock chamber, positioned one above the other. At the Uelzen II lock, the water-saving basins hold about 70% of the water needed to fill the lock chamber, which is somewhat more than at Uelzen I.
Ja, komm langsam ran. Ich habe hier unten eine Kammer vorliegen, zweite Kammer für dich dann, ne?
For the sake of repair and maintenance work, and for peak times with up to 86 lockage operations a day, Uelzen I is also still in commission, on 362 days a year.